This video is about solving separable differential equations, format like this. Your goal is to make all x on the right side, all y to the left side. So we multiply by dx both sides. dy equals f of x times g of y dx. Then we divide it by g of y both sides, so that you will get the dy over g of y equals f of x times dx. Then you can do the integral both sides to solve for y. So let's talk about some more facts. E to the x plus c, we can write down a times e to the x power. Both a and c are constant. So for e to the x plus c's power, we can separate like e to the x power times e to the c's power. Let's make a equals e to the c's power, so that we can write down e to the x plus c equals e to the x times a. Rewrite this one is a times e to the x power. For natural log x plus c, we can write down this way. Still, we will make a equals e to the c's power. Then we take natural log both sides. You will get the natural log of a equals natural log of e to the c's power. Here's the formula. We know log base a to the ax power equals x. So we have natural log e to the x power equals x. This one you can get c here, natural log of a. Therefore, natural log x plus c, I can write down natural log x plus natural log of a, so that I can do natural log of a times x. Let's solve for y. Before we get started, let's over some more formula. We know the a to the log base a of x power, you will get the x. Therefore, if you have e to the natural log of x equals x, 10 to the common log of x equals x. If you have log base a to the ax power equals x, so natural log of e to the x power equals x. Common log 10 to the x power equals x. Try to remember this formula for logarithm. So for the first one, we will take natural log both sides. You will get the natural log e to the y's power equals natural log f of x plus c. According to this formula, you can get the y equals natural log f of x plus c. Second question. Natural log y equals f of x plus c. You will take a power both sides, make e as the base, so you get the e to the natural log of y equals e to the f of x plus c. According to this formula, you will get y equals e to the f of x times e to the sixth power. We can make e to the sixth power as a, so we get the a times e to the f of x power. That's y equals.
Number 1, dy by dx equals negative 2xy squared. For the separable differentiated equations, you need to set up dy f of y equals dx, here's f of x. Then you can do integral both sides to solve this y. So first of all, we need to get dy equals negative 2xy squared and dx. Then both sides divided by y squared. So you get 1 over y squared dy equals negative 2x dx. Then we will do integral both sides. For 1 over y squared, we know that is y to the negative second power. Integral about that equals negative 2 add 1 will be negative 1. Y is negative first power. So basically means negative 1 y. Negative 1 over y equals. Over here, you will get the negative 2 times x squared over 2, then plus c. Therefore, you will get negative 1 over y equals reduce negative x squared plus c. This time, we can plug over here. When x equals 1, then you will get the y equals 1 over 4. Therefore, you will get the negative 1 over 1 over 4 equals negative 1 squared is 1 plus c. Jump to the front, you will get negative 4 equals negative 1 plus c. Therefore, c equals negative 3. So we can write down the form like this. Negative 1 over y equals negative x squared minus 3. Both sides we multiply by negative 1. Get the opposite. 1 over y equals x squared plus 3. Then we do cross multiply. Y equals 1 over x squared plus 3. This will be the solution to the question. Let's go to number 2. For number 2, same thing. We need to set up f of y dy equals f of x dx form, so that we can do the integral both sides to solve for y. So you will get the dy tangent x equals both sides times dx, tangent y times dx. Both sides divided by tangent y times tangent x. Reduce. You will get the dy over tangent y equals dx over tangent x. Let's look at this fact. We have integral of tangent x dx equals integral sine x cosine x dx. We will set up u equals cosine x. Therefore, du equals negative sine x dx. Then dx equals du over negative sine x. Therefore, we will plug in here. You will get the integral sine x stay. This cosine x I turn into u. dx, I will use du over sine x, negative sine x, to substitute, then reduce. You will get integral negative 1 over u du. That equals negative 1 times the natural log of absolute value of u plus c. So we can write down negative natural log of absolute value of u plus c. For the u, that is cosine x, then plus c. Let me move this negative 1 to the top. That means natural log of absolute value of secant x plus c. Worse, when we have tangent x dx, you will get natural log for absolute value of secant x plus c. What about cotangent x dx? That equals cosine x over sine x dx. This time we will set up u equals sine x. So we have du equals cosine x dx. dx equals du over cosine x. So that you will get cosine x u times du over cosine x. Reduce. You will get natural log of absolute value of u plus c. Natural log of absolute value sine x plus c. Here's the rule. Integral cotangent x dx equals natural log absolute value sine x plus c. Let's make a equals e to the 6th power. Therefore, c equals natural log of a. So that I can write down integral cotangent x dx equals natural log of absolute value sine x plus natural log of a. Then I condense. You will get the natural log a times absolute value sine x. For this c, I will do the same thing. A equals e to the 6th power, and c equals natural log of a. Therefore, you will get the natural log a times absolute value secant x. Now we get these two formula. If possible, try to remember this. For dy over tangent y, we can write down cotangent y dy equals cotangent x dx. Then we will do the integral both sides. Then we got to use this formula here. You will get natural log absolute value sine y equals natural log a times absolute value of sine x. So both sides to the east power, you will get absolute value sine y equals a times absolute value of sine x. So for sine y equals plus or minus a times sine x. This will be the final solution.